Okay, here's a difficult example. I'll go through it. Okay, let's look at this example. First off, let's do some algebra. And let me scroll up. Do I need to, let me see, let me scroll up. Sorry. Here's what we're going to do. I'm going to let x go to infinity. It doesn't matter which infinity. I'm going to let, what would this guy equal, is that, what would this guy tend toward, I should say, is x tends toward either infinity. So first let's do some algebra. I'm going to do conjugate, like I'm going to multiply, like if I treat this guy as, let's just call it capital A and this guy capital B. So here's A minus B, here's capital A plus B. And of course, since I inserted capital A plus B here multiplicatively, I have to bring it down here. Okay. And so by difference of squares, I do A squared minus B squared, but the square root is just the guy himself. So this guy right here is my A squared minus parentheses, and these parentheses are important, don't leave them out, B squared, but again, the square and the square root cancel each other and we just get the 6x squared plus 1. Now the 6x squared plus 1 in and of itself is my B squared. So I've got A squared minus B squared. And on the bottom I just leave it B. And I probably need to create some space just for neatness, but I don't know if it'll let me. But this is the next line down here. So now the 6x squared, if I distribute the minus sign, that's going to become minus 6x squared minus 1 right here. So minus 6x squared minus 1, because that minus is going to distribute through those parentheses and hit both terms. But the 6x squared and the minus 6x squared are going to cancel. The negative 5 and the negative 1 will make a negative 6. And the plus x is just x itself. It just sticks on there. There's nobody for it to really go with. So it just copies and pastes over here. So this is just x minus 6. And again, I'll leave the bottom alone. But wait, now there's one other thing I'm going to do though. I'm going to do another trick. I'm going to divide the top and the numerator and denominator. I'm going to divide them. Well, oops. It's not, MATLAB is not going to do what I wanted it to do, but it's okay. I'm going to divide the top and bottom by x. So that this is the next line down here. I'm sorry this runs together. It's just not going to let me space these. I'm not happy with the spacing, but it'll just have to be. So x minus 6, I'm going to turn into x minus 6 over x. And this denominator here, this is my capital A plus capital B. I'm going to write that as capital A here plus capital B all over x. So I'm just dividing the numerator overall by x and the overall denominator by x. Now, the spacing there, again, this is not the best. This is on another line right here, starting from this x minus 6 all the way down. Okay, but moving on to the next page. But remember, x minus 6 over x, that's x over x minus 6 over x, but x over x is 1. We're assuming x is not 0. But anyway, we're tending to infinity, so we don't have to worry about x we're assuming x is not 0. That's not even an issue, because we're going to tend toward either positive or negative infinity. So we get 1 minus 6 over x, and then down here, well, now I'm going to do a little sleight of hand. I'm going to write x as the square root of x squared. And you know what? Nix negative infinity. Forget negative infinity. Let's tend to positive infinity, because if I was tending to negative infinity, I would have to stick a negative sign out here where my cursor is. So let's just do positive infinity, okay? So x does equal the square root of x squared as long as x is positive. And if x is negative, x would equal an outside negative times the square root of x squared here, okay? But let's go to positive infinity so we don't have to worry about that. Going to negative infinity wouldn't be radically different at all, but I'd have to stick a negative right here, and I don't want to fool with it. Okay, so, but anyway, and indeed, in this example, we're going to go to positive infinity, so we don't have to worry about it. So, you're like, well, Jason, why did you write this as the square root of x squared? Even so, because I can bring this inside. I can divide each of these three guys by, I can write this as remember, the radical, the quotient of radicals is the radical of the quotient as long as everybody's positive. And everybody's going to be positive because x is going to go indefinitely toward positive infinity. So I can bring this together and write this as radical this over radical this. plus radical this over the same denominator, radical this. So 6x squared over x squared is 6. X over x squared is x on the, 1 over x, excuse me. 1 over x. And then minus 5 over x squared is just that, minus 5 over x squared. And then separately, then close out the radical, hit a plus sign, open up another radical. And again, 6x squared over x squared is 6. And then plus 1 over x squared as is, all inside the radical. Okay? And that's, okay, and it's going to, so hence it follows that this guy right here, the limit as x goes to infinity of the guy that we had in the very beginning, this guy right here, equals the limit x goes to positive infinity of this guy that we got now, that we had to do all that work to get. But that's good. We like this guy a lot better. With this guy, we had infinity minus infinity. That's sticky. We can't really do anything with that. With this guy, we don't. In fact, the limit as x goes to infinity tends to something down here that's not 0. So the quotient of the limit is the limit of the quotients. And indeed, the limit of x goes to infinity of this. And in fact, you can bring the limit inside the radical here and do limit this plus limit this plus limit this. But these are the 1 over x is going to disappear to 0, and so and so is 5 over x squared. It's going to also disappear to 0. So this just limits to radical 6, and so does this. The 1 over x squared is just going to die off to 0. So we get 6 plus 0, or, well, minus 0, but it doesn't matter here. And then here we get 6 plus 0, so we just get radical 6 plus radical 6. That's 2 radical 6. And now this limit up here, the minus 6 over x is going to die off. And so that limit right here, that's just going to tend to 1. So we just get 1 over 2 radical 6. You can stop there. It depends on if your college instructor, if he or she insists, if she or he insists that you rationalize the denominator, then what you need to do is multiply the bottom by radical 6 and the top by radical 6. This is from Algebra 2, or maybe Algebra 1, I don't remember. It's either Algebra 1 or Algebra 2. You multiply the top and bottom by radical 6, and you would get radical 6 over 12. Because 2 radical 6 would be the 2, by associativity, you can multiply the rad 6, you'd get 6, and then 6 times this 2 would be 12, and then you'd have 1 times radical 6, which is just plain radical 6 up here, okay? So there's that. That was a tough example, but I wanted to go through and do it. It's all about conjugation, but anyway, moving on. You do this example, and you'll need to go through all the steps and the motions, okay? Next, let's do something a little different for the time being anyway. The limit of x goes to 0 of this guy right here. Now this is sticky. We'd get a 0 up here, and it's a numerator of fractions, and that's never enjoyable, or at least not to me anyway. Yeah, we'd get a half minus, we'd tend toward a half, and a half minus a half is 0, so this overall numerator as a whole would tend to 0, and the denominator, of course, would tend to 0. So what we need to do is get a common denominator. So remember, we can combine the fraction like this. You'd get 2 minus parentheses x plus 2, but that minus distributes. I went ahead and did the arithmetic here in the algebra. So you'd get this, getting a common denominator and bringing it together, you'd get this. But hey, 2 minus 2 is dead, and that just leaves negative x behind. And I just yank the negative out to the side right here where my cursor is. So I have the negative of x over, and you see this, and I have the same old 2x plus 2 and the same old x down here. But by the rules of algebra, I can bring this guy right here down multiplicatively with this x down here. So I can just bring the 2x plus 2 multiplicatively down here with this x, and I'd get 2x, x plus 2. That's by the rules of algebra and arithmetic. And I brought the negative back up here with the x. Okay, but hey, lo and behold, this x and this x will cancel. They were the ones causing the trouble anyway, and I get negative 1 over 2 over just the 2x plus 2. But remember, now, but I could go and distribute and call this 2x plus 4 down here. I just didn't, without the parentheses, but I just didn't bother. But hey, we can, by continuity, we can just throw 0 into x here. The limit of the quotient is a quotient of the limits now. And we just get negative 1 over 2 times 0 plus 2 is 2 right here. but 2 times 2 is 4, so we get negative 1/4. And guys, I'm sorry how this got printed out. This is the fraction negative 1/4 here, and I'm sorry it looks so weird, okay? My apologies about that. So y equals negative 1/4 is our horizontal asymptote. Yeah, sure. Wait, no it's not. Yeah, no it's not. Not sure. And the answer is, that's not a horizontal asymptote. This limit did not go to infinity. It went to 0. Oops. Sorry, guys. Sorry, that's not true. I said something there that was bogus. Horizontal asymptote, remember, this is a teachable moment. That's the limit when x goes to either positive or negative infinity, not when x goes to some finite number, whether it be 0 or 2 or whatever. No. X has to go to one of the infinities. So that's all for that one. And you do this example right here. And let's see, what else? So moving on down. Now in a similar fashion, like we did the last example, I won't go through this over every detail, but if this is big A and this is big B, you multiply the top and bottom by big A plus big A here, plus big A plus big B. So I multiply the top and, really, the bottom, there was no bottom here. It's understood to be 1. But since I multiply by A plus B, I have to divide everybody by A plus B. And remember, you do A squared minus B squared, difference of squares. That just strips off the radical symbol, and you just get x squared plus x minus 5 as is, minus the whole quantity x squared plus 1. Now this minus is going to distribute. You're going to get minus x squared minus 1 and drop the parenthesis. And now negative 5 minus 1 is, of course, negative 6. And then the x just sticks on. The x squareds cancel out. And again, I divide the top and bottom by x, and I simplify the top. The bottom, I kind of unsimplified in a sense. I turn x into the radical of x squared, and I don't put a negative out here because I'm tending toward positive infinity, not negative infinity. And again, I just divide all of these guys. I divide all these interior guys by the interior x squared, like x squared over x squared is 1, x over x squared is 1 over x. And I do it for this one, I do it for this one and this one. I divide them all by x squared, and they're all inside the radical hat. Now be careful, you'll need to close off this radical here, put the plus sign, and then open up this new radical here. And so it follows that this limit will equal this limit. You know, we showed that they're the same, that these are one in this, that this interior is the same as this interior of the limit. So, or the interior of this limit right here is this guy right here equals this guy right here is what I'm saying. And so, but now the limit of the quotient is a quotient of the limits, and we wind up getting 1/2. And yes, now this is true. This is safe and it's good. Our horizontal asymptote, yes, it is y equals 1/2 because we tended toward positive infinity. But anyway, there's that. Okay. And yeah, that's good for that. So now you do this limit right here on your own, okay? Now, finally, we get to the one of the most important topics of calculus, and in a way, calculus 1, that's why we're here, the derivative. Let's do this on the next video. I want you to be fresh mentally when you see the definition of the derivative, because that's really the reason why we're here as far as calculus 1 is concerned, or a big reason why we're here. It may not be all the reason, but it's probably the heart and soul of calculus 1 in many ways. It's the derivative. It's what I've kind of been eager to get to. So let's close this video off. Thank you guys. I'll see you on the derivative lesson.